The idea that God created the universe went largely unchallenged until the Middle Ages, when scientists made a sacrilegious suggestion based on their observations. The sun, not the Earth, was at the center of the universe.
It was a paradigm shift. There is now another way to explain the naturally occurring phenomena around us, and this is science.
Since the Middle Ages, scientists have developed sophisticated new theories about the enormity of the universe and our place in it. Theories that often have no room for God.
Many phenomena have appeared mysterious or miraculous or magical. And then through the process of science, we've eventually understood them. Scientists gradually realized that the sun really is just one star among a multitude of stars in a gigantic galaxy having hundreds of billions of such stars. And all this was created in a Big Bang 13.7 billion years ago.
But while scientific theories, observations, and experiments tell us where we are in the cosmos, they don't answer the eternal questions: why we're here, and who, if anyone, created us.
The amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution weren't created at the beginning of time. They're created in the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today, okay? And anyway.
By the end of the 1920s, astronomer Edwin Hubble, working with the large 100-inch telescope atop Mount Wilson outside Los Angeles, had established that our galaxy was only one of many galaxies in the universe.
When we look out at other galaxies, on average, they're moving away from us. And those that are twice as far away are moving twice as fast, and those that are 3 times as far away are moving 3 times as fast. And of course, that makes us look like we're the center of the universe.
Such a condition would imply that we occupy a unique position in the universe, analogous, in a sense, to the ancient conception of a central Earth. This hypothesis cannot be disproved, but it is unwelcome and would only be accepted as a last resort in order to save the phenomena. Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable.
Several decades ago, we found a problem so great that it was brushed under the carpet for many a decade. And this is the fact that galaxies spin too fast. In fact, 10 times too fast. By rights, the galaxy should fly apart. Therefore, scientists said that we have to have dark matter, a halo of matter that surrounds the galaxy and holds the galaxy together.
And what have they discovered? Absolutely nothing. Zilch. What is a little bit perturbing is that after 50 years we still haven't found what the dark matter is. But on the other hand, that doesn't mean they're not there, it just means they're harder to find than we thought.
We look out in the universe and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really we should be calling it the dark force, because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is just simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. It is the longest standing unsolved problem in modern astrophysics. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
So the problem with cosmology is that we keep inventing theories, ad hoc theories, to try to explain the data, such as inflation, dark matter, dark energy. and so on, just to keep patching the theory up.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
A very large number of universes, perhaps even an infinite number, could in principle exist in a vast hyperspace.
We can understand the idea of hyperspace by comparing it to a mug of beer.
Beer. The beer mug would be the hyperspace, and the bubbles would be these individual universes. The bubbles in a beer mug are all physically about the same. But suppose they span a range of properties. Some of them might have carbon and oxygen and stars and gravity, and others don't. We would be in one of the ones that leads to a rich, complex universe culminating with life as we know it.
If there are an infinite number of other universes, the fine-tuning that seems to be present in ours isn't an example of God's plan, but rather the law of statistics. Most of these universes wouldn't naturally develop in ways that fostered intelligent life, but a few would.
So then the explanation for the specialness of the universe is that we are winners in a gigantic cosmic lottery. It stands to reason that we couldn't be living and discussing this in a universe that was hostile to life. Only the bio-friendly ones get populated with thinking beings.
Having a multitude of universes is actually quite a simple and natural consequence of some of the most favored models for the birth and early evolution of our universe. It's kind of like stars and planets. As long as you have the capacity to make one, it's easy to make lots of them.
Oh, really?
Wow! Beer mug hyperspace multi-bubble verse. Really?
Beer.
Seriously? They're farting out beer bubble universes. Okay? That's what they're doing. Hey, I got an idea. Yep. Multi-beer bubble universe. And they call that science. And they make fun of us? Really? Yeah, I'm not going to take that from them anymore. I'm not going to sit here and let people who think they came from monkeys out of a beer bubble universe ridicule me for looking into what I'm looking into and considering, a possibility. If you guys can think about beer bubble universes, then I can think about a snow globe. Fair enough? Okay, let's move on. Thank you. That's what they're calling science. So again, Christian, if you're worried about looking stupid, look at what they believe. Wow. It just gets crazier and crazier. I mean, talking about being off by 10 to the 120th power. Really? I think Nikola Tesla had it right, and he was starting to see it already in his day, in the beginning of the 20th century, right? Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality. That's exactly what's happening. And you're seeing more and more articles popping up like this. This is just from a few months ago, April 30th, 2019, Scientific American. Cosmology has some big problems. If you read the article, it talks about, this individual right here says, compounding this problem, most observations of the universe occur experientially and indirectly. Pay attention here. Today's space telescopes provide no direct view of anything. They produce measurements through an interplay of theoretical predictions and pliable parameters in which the model that they've concocted in their head is involved every step of the way. The framework literally frames the problem. It determines where and how to observe. And so, despite the advanced technologies and methods involved, the profound limitations to the endeavor also increase the risk of being led astray by the kind of assumptions that cannot be calculated. He goes on to say, a key piece of the Big Bang paradigm was criticized by one of the theory's original proponents for having become indefensible as a scientific theory. Why? Because inflation theory relies on ad hoc contrivances and to accommodate almost any data, and because this proposed physical field is not based on anything with empirical justification. This is probably because a crucial function of inflation is to bridge the transition from an unknowable Big Bang to a physics we can recognize today. So is it science or a convenient invention? He concludes his article by admitting, quote, in order to maintain a mathematically unified theory valid for the entire universe, we must accept that 95% of our cosmos is furnished by completely unknown elements and forces for which we have no empirical evidence whatsoever. I just summarize that by saying, you know what is taught today as fact is really nothing more than unproven ad hoc theories based on presupposition derived from outlandish conjecture, which itself was contrived from sheer fantasy, all of which ends up beautifully illustrated by the hands of artists and published in textbooks as self-evident truth. That's what science has turned into today. All right, so let's move from the origin of the cosmos to issues of the earth and talking about the age of the earth and so forth. How old is the earth and how do we know? Well, for a long time there's been sort of this war between the ideas of uniformitarianism versus the older ideas of catastrophism. Charles Lyell's multi-volume Principles of Geology was published in the early 1830s. Its subtitle was an attempt to explain the former changes of the Earth's surface by reference to causes now in operation. He was one of the major advocates of an idea known as uniformitarianism, that the Earth was shaped entirely by slow-moving forces still in operation today, acting over a very long period of time. This stood in direct opposition to catastrophism, which described geological changes coming about as the result of abrupt, violent changes. Thus, characters like Charles Lyell looked at the stripes in the rocks, right, and he just assumed millions of years. No proof, nothing. That's the best. That's his best explanation right there. But is it really the best explanation for what we see, and how accurate are our dating methods to begin with? I'm reminded of an analogy Kent Hovind used to give, talking about a creationist and an evolutionist looking out over the Grand Canyon. One of them looks at the Grand Canyon and says, wow, look at what the Colorado River did over millions of years. And the creationist says, wow, look what the flood of Noah did in a couple days. You know, your preconceived bias, right, determines how you look at the thing. Now, I already told you I come from a biblical worldview, so let's have a look at what the Bible has to say as a more plausible explanation for some of these things. And interestingly enough, as a young person, I stumbled across the works of this guy right here. How many of you ever heard of Immanuel Velikovsky? Anybody? Not a lot of people here. A couple of interesting books right there, Worlds in Collision and Earth in Upheaval. Those two books actually were instrumental in leading my dad to Christ in a bar in Vietnam. A guy was selling books there. He got those books, started reading them, and my dad was more like an agnostic at the time. But it got him to begin to question the paradigm and evolutionary thought and whatnot, and eventually he became a Christian himself. So those two books have quite a bit of meaning to me on a personal level. But here's a little video I cut together from some of the creation ministries talking about a better explanation for the geological features and the dating of the Earth.
What about the age of the Earth? Isn't there evidence for millions of years? And how do we understand all that? Well, first of all, let's look at what the Bible says. If you take the days of creation as ordinary days, and you take all those genealogies in Scripture, if you add it all up, 5 days before Adam, from Adam to Abraham, and then you add up from Abraham until today, you get about 6,000 years. Now, what about all the dating methods that seem to indicate billions of years? Actually, there are hundreds and hundreds of dating methods that you can use to age date things on the Earth. See, one creation scientist I know makes this statement. He says 90% of the methods you can use to age date things on the Earth contradict the billions of years. Only 10% even seem to give the billions of years. But all dating methods have fallible assumptions.
Nearly every textbook and science magazine teaches that the Earth is billions of years old, and the primary dating method used for determining this is what is called radioisotope dating, or radiometric dating. Now, this is a reliable method for measuring absolute ages of rocks and the age of the Earth, right? First off, many scientists now regard the age of the Earth to be between 4.55 and 4.6 billion years old. Okay, so if this method is reliable and accurate, why the 50 million year discrepancy? That seems like a lot. But let's get into some details here and see what's going on. Keep in mind that there's all kinds of scientific jargon on this topic, and so we'll just present a very straightforward, simplified version. Radiometric dating is the process of estimating the ages of rocks based on the decay into other kinds of atoms. For instance, uranium will radioactively decay through a series of steps until it becomes the stable element called lead. The original element is called the parent element, and the end result is called the daughter element. Radioisotope dating is commonly used to date igneous rocks, rocks which formed when hot molten material cooled and solidified. The dating clock started when the rock cooled. During the molten state, it is assumed that the intense heat forced any gaseous daughter elements to escape. It is assumed that once the rock cooled, no more atoms escaped, and any daughter element now found in the rock is a result of radioactive decay since that rock formed. The decay rate is measured in terms of half-life. That is the length of time it takes half of the remaining atoms of a radioactive parent element to decay. Now, of course, that can be measured in a laboratory, and it is assumed that since we know the decay rate, we can calculate backwards and come up with the age of the rock. But is that all there is to it? Here's where it gets tricky. It's true we can measure a decay rate using observational science, but there's another kind of science that is required to accurately calculate dates for rocks, and that is what we call historical science. Historical science deals with the things in the past, and therefore it cannot be repeated and tested. Dating methods require both types of science, because in order to get accurate rock dates, one would have to accurately know both the decay rate and the initial conditions of the rock sample, right? Since radioisotope dating uses both types of science, we can't directly measure the ages of rocks. There are assumptions involved. For instance, how do we know what the initial conditions were in the rock sample? How do we know the amounts of parent or daughter elements now in that sample haven't been altered by other processes in the past? How does someone know the decay rate has remained constant since the rock formed? The answer is they don't. Let's simplify here and talk about a typical hourglass. Let's say you walk into a room and you see an hourglass with sand at the top and sand at the bottom, and some sand sprinkling from the top chamber to the bottom. Well, observational science would allow us to see and measure the sand, and then calculate how long the hourglass has been running, right? We could make our sand measurements and then calculate when the hourglass was turned over, right? Well, those calculations could be wrong, because we may have failed to consider some major assumptions, like, was there any sand at the bottom when the hourglass was turned over? Has any sand been added or taken out of the hourglass? Has the sand always been falling at a constant rate? Since we did not observe the initial conditions when the hourglass started, and we haven't been watching the sand all the time since then, we must make assumptions. All three of those assumptions can affect our time calculations. Now, of course, there's more to understanding all of this, but enough said.
The Earth's surface is scarred by deep canyons, cut into solid rock. But how did they form? A little bit of water over a long time, or a little bit of time with a lot of water? Modern rivers don't generally cut downward into solid rock, so today's river erosion seems incapable of explaining rock canyons. The Great Flood of the Bible, however, provides a possible explanation for such canyons. On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark.
Now eventually lava flows formed a new dome, 5 new domes actually, all of which were destroyed by subsequent eruptions. But the 6th dome that formed between October 1980 and 86 is what you see today. It's composed of 2.6 billion cubic feet of lava, and it's quite young, having finished forming just over 30 years ago. Well, in 1996, geologists sent rocks from the lava dome to be radiometrically dated. Now, they used a method called potassium argon. Well, scientists measured how much potassium and how much argon are in the rock, and they calculate the age of the rock, right? But creation scientists have pointed out for years that there are some major problems with radiometric dating. One big one is all of the assumptions that it's grounded on. You must assume that the half-life is constant and that it never varies. You have to assume that there was no contamination. For example, no argon was present in the sample before the decay began. Well, that's a lot of unprovable assumptions. Now, if radiometric dating and the assumptions that it's founded on were accurate, well then Mount St. Helens rocks should have yielded very young ages. After all, the rock was merely about a decade old. You see, the problem is, they didn't. The rock gave an age of 350,000 years. When they dated the minerals within the rock, the problem got much worse. They gave dates of 2.4 million years. This is for a 10-year-old rock. Now, Mount St. Helens highlighted that we shouldn't blindly trust the dates given by radiometric dating. The assumptions clearly aren't accurate, so the dates that they give are also inaccurate. Instead of trusting a method that doesn't even give correct ages for rocks of known age, well, maybe we should trust the Bible's history, which tells us that our Earth is around 6,000 years old.
Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. At Mount St. Helens, a single mud flow off the mountain carved Engineers Canyon out of soft sediment in a single day, 100 feet deep. And the same thing even happened in solid rock. A series of mud flows created Lewitt and Step canyons on the front face of Mount St. Helens, cutting hundreds of feet into solid rock over just a few years. Grand Canyon is a good example where we find evidence of catastrophic forces at work. Upstream is evidence of huge lakes. These lakes would never have formed if the canyon were already open below them. However, if these lakes had formed from rains after Noah's flood, and if the pressure of these waters broke through and carved through the recently deposited sediments, then we would expect to find surge deposits downstream. Below Grand Canyon, this is precisely what we find. Evidence of a lot of water cutting over a little bit of time. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present.